Hi, this is Ruki. Welcome to Math Key. Today we are looking at an important topic in mathematics, solving quadratic equations by completing the square method. This method may have seemed a little bit confusing, but it's actually one of the easiest ways of solving quadratic equations. If I already understood how to solve a given quadratic equation using the factorization method, why then do I still need to learn how to do that using completing the square method? You need to learn how to do this for two simple reasons. Not every quadratic equation can be solved by factorization method. However, completing the square method works for all quadratic equations, even if the equation is not factorizable. Secondly, one may be limited to using completing the square method. Let's now see how to solve quadratic equations by completing the square. Recall that the general form of every quadratic equation is ax squared plus bx plus c equal to 0, where a is not 0. To solve this equation by completing the square, the following simple steps should be taken. Move the constant term c to the right-hand side of the equation. Ensure that the coefficient a of x squared is 1. If not, divide through the entire equation by a so that the equation takes this form. After step 2, identify the coefficient of x in the equation. Get half of this coefficient, take the square, then add this result to both sides of the equation. Having done these three simple things, we simplify the resulting equation. To make sure that you understand exactly what we are saying, let us solve a couple of quadratic equations using completing the square method. First is to move the constant term plus 12 to the right-hand side of the equation. Step 2. The coefficient of x squared is already 1, so we do not need to divide through by that. Step 3. The coefficient of x is negative 7, and half of this is negative 7 over 2. We take the square of this and add this result to both sides of the equation. Let's now simplify this. The two terms carrying the square at the left-hand side can be combined. We sum these two terms, then square the result. Note that expanding this bracket reproduces the previous step. Therefore, everything is still in place. At the right-hand side, we have negative 12 plus 49 over 4, which eventually turns into this. So, we take the square root of both sides just to get rid of the square at the left-hand side of the equation. Note that taking the square root of both sides introduces the positive or negative operation. From the square root table, the square root of 1 over 4 is 1 over 2. This therefore implies that x equals 7 over 2 plus or minus 1 over 2, which splits into these two forms. Hence, x equals 4 or 3. Very much unlike this example in which the coefficient of x squared is 1, what if the coefficient is not 1? Maybe 2, 3, negative 2, or even a fraction. How do we do such? Well, like we said earlier, in cases like that, we divide through the equation by that coefficient. Let's see this example to make things really easier and cool. Again, the first thing to do is to move the constant term minus 3 to the right-hand side of the equation. Next is to divide through the entire equation by the coefficient of x squared to have this new form. Next step is to identify the new coefficient of x. And half of this coefficient is minus 1 over 5. Now take the square of minus 1 over 5. Add this result to both sides of the equation. While the left-hand side becomes x minus 1 over 5 in bracket all squared, the right-hand side becomes 3 over 5 plus 1 over 25, which further simplifies to 16 over 25. We take the square root of both sides. Hence, x minus 1 over 5 equals plus or minus the square root of 16 over 25. From our square root table, the square root of 16 over 25 is 4 over 5. Therefore, x equals 1 over 5 plus or minus 4 over 5 by rearranging. Also, this splits into two forms. Hence, the solutions of the equation are 1 or minus 3 over 5. Lastly, let's see how we can use this method to solve a quadratic equation that cannot be solved by factorization method. We move the constant term minus 6 to the right-hand side. Divide through the entire equation by the coefficient of x squared to get this new form. Half of the new coefficient of x is 5 over 6. Take the square, then add this result to both sides of the equation. The left-hand side now becomes x plus 5 over 6 in bracket all squared, and the right-hand side now becomes 2 plus 25 over 36, which simplifies to 97 over 36. We take the square root of both sides, and the new equation becomes x plus 5 over 6 equals plus or minus the square root of 97 over 36. Notice that this time, the numerator 97 is not a perfect square. That's because the equation we are dealing with is not factorizable. So from the calculator, the square root of 97 is approximately 9.85, and the square root of 36 is 6. Therefore, x equals minus 5 over 6 plus or minus 9.85 over 6. Hence, x is approximately 0.81 or minus 2.48 after dividing. Therefore, the solutions of the quadratic equation are 0.81 or minus 2.48. A quick summary of what we have learned. Completing the square method can be used to solve a quadratic equation even though it cannot be solved by factorization. To solve any quadratic equation by completing the square, we first move the constant term to the right-hand side. Divide through the entire equation by the coefficient of x squared if it is not 1. We get half of the new coefficient of x, square the half, add this result to both sides of the equation, then we simplify. For more free worked examples on completing the square, exercises and answer keys, visit our website or check the link in the description below. Thanks for watching and do have a lovely day. Bye.